Hi everyone, welcome to Smita data mining channel. Today my video is about cluster analysis and types of data in cluster analysis. What is clustering? Clustering means a collection of data objects. It is similar to one another within the same cluster and dissimilar to the objects in other clusters. Clustering is also called data segmentation. Clustering is an example of unsupervised learning. What are the applications of cluster analysis? As a standalone tool, it gets insight into data distribution. As a pre-processing step for other applications, it can be used for market research, data analysis, pattern recognition, image processing, earthquake studies, climate. Clustering is also used for outlier detection. Outlier applications such as detection of credit card fraud, monitoring criminal activities in e-commerce. What are the qualities of good clustering? A good clustering method will produce high quality cluster with high intra-class similarity and low inter-class similarity. Quality measured by its ability to discover some or all the hidden patterns. This is the figure showing intra-cluster distance are minimized and inter-cluster distance are maximized. Desired features of cluster analysis: scalability, ability to deal with the different types of attributes, discovery of clusters with arbitrary shape, minimal input parameters, ability to deal with noisy data, high dimensionality, interpretability, and usability. Types of data in cluster analysis. First is data matrix. It is a two-mode matrix. It is represented n objects, person with p variables such as age, height, gender, and so on. Structure is in the form of relational table or n by p matrix. N by p matrix can be represented like this, and dissimilarity rest is dissimilarity matrix. Stores a collection of proximities that are available for all pairs of n object, represented by an n by n table. Dij measured as difference or dissimilarity between objects I and j. Dissimilarity matrix is also called one-mode matrix. Data are represented in the form of data matrix. It can first be transformed into dissimilarity matrix before applying clustering algorithms. Interval scaled variables. Continuous measurement of a roughly linear scale. Typical examples include weight and height, latitude and longitude coordinates, and weather temperature. The measurement unit used can affect the cluster analysis. To avoid dependence on the choice of measurement units, data should be standardized. To standardize measurements, convert the original measurements to unitless variables. Given measurements for a variable f, we can calculate the mean absolute deviation SF is equal to 1 by n absolute value of x 1f minus x mf plus x 2f minus m12 plus x nf minus mf, where x 1f, x 2f up to x mf are n measurements of f. Mf is the mean value of f. Mf is equal to 1 by n xi1 plus xif plus x2f plus up to xnf. We can calculate the standard measurement or Z score. Zif is equal to xif minus mf by sf. Dissimilarity between objects described by interval scaled variables. The most popular distance measure is Euclidean distance. It can be calculated by the formula Dij is equal to root of xi1 minus xj1 the whole square plus xi2 minus xj2 the whole square plus xin minus xjn the whole square, where I is equal to xi1, xi2 up to xin, j is equal to xj1, j2 up to xjn up to n-dimensional data objects. From these portions, questions are asked for K2 exam. Another well-known matrix is Manhattan distance. Dij is equal to absolute value of xi1 minus xj1 plus absolute value of xi2 minus xj2 plus up to xin minus xjn. Both Euclidean and Manhattan distance satisfy the following mathematical requirements. Dij is greater than or equal to 0, where distance is a non-negative number. Dii is equal to 0, distance an object to itself is 0. Dij is equal to dji, distance is a symmetric function. Dij is less than dih plus dhj. Minkowski distance is a generalization of both Euclidean distance and Manhattan distance. It can be found by dij is equal to xi1 minus xj1 raised to p plus xi2 minus xj2 raised to p up to xin minus xjn raised to p the whole raised to 1 by p, where p is a positive integer. P is equal to 1 for Manhattan distance and p is equal to 2 for Euclidean distance. Another representation is binary variable. It has only two states, 0 or 1. 0 means absent and 1 means present. The similarity between two binary variables are computed from the given binary data. If all binary variables having the same weight, we can create a continuously table. This table is represented by like this. Here a is equal to number of variables that equal 1 for both I and j. B is equal to number of variables that equal 1 or for object I but that are only for object j. C is equal to number of variables that equal to 0 for object I and 1 for object j, and D is equal to number of variables that equals 0 for both object I and j. P is equal to A plus B plus C plus D, that is the total number of variables. A binary variable is symmetric if both of its states are equally valuable and carry the same weight. This similarity based on symmetric binary variable is called symmetric binary dissimilarity. It can be calculated by the formula dij is equal to r plus s by q plus r plus s plus t. A binary variable is asymmetric if outcome of the states are not equally important. Dissimilarity based on such variables called asymmetric binary dissimilarity. Dij is equal to r plus s by q plus r plus s. Asymmetric binary similarity can be found by the given formula q by q plus r plus h. Another is categorical variables. Generalization of binary variable. It can take more than two states. Variables can be denoted by letters, symbols, or integers. The similarity computed between objects is computed by dij is equal to p minus m by p, where m is the number of matches, p is the total number of variables. Next representation is ordinal variables. In ordinal variable, it can be discrete or continuous. Its order is important. Example, rank. It can be treated like interval scaled. Then another type of variables is ratio scaled intervals. It is a positive measurement on a nonlinear scale such as exponential scale. It is found by a into e raised to bt or e raised to minus bt. Methods. First treat them like interval scaled variables and apply logarithmic transformation y is equal to log x. Finally, treat xif as continuous ordinal data and treat their ranks as interval valued. Another is representation is vector objects. It is popular similarity function to compare two objects. Vectors x and y is cosine measure. So the different categorization of clustering methods. Major clustering methods can be classified in the following categories: partition methods, hierarchical methods, density-based methods, grid-based methods. If you like the video, you subscribe. I will come with the next video. Till then, bye.